Hi, so today on the bottom line, we're speaking with Vignesh. He's the founder of Par Autonomy.
The way future wars are going to be won is through software. We want to democratize the ability to perceive threats and autonomously respond to them.
How would you describe the current state of India's defense technology ecosystem? What is happening? Where are we standing in terms of, say, the global ecosystem? What form of government intervention, surveillance from, say, the authorities is into picture when you're building a defense tech company in India? What is the level of autonomy do you have with respect to choosing what to make and, of course, choosing who to sell to?
A lot more money needs to go to the bottom of the scale, right? Where the chance of failure is also way, way high, right? And that's the weird thing about technology is that the bottom of the stack is where the failure rate is the highest. The top of the stack is generally a lot more stabilized and can be a lot more successful.
Hi, so today on the bottom line, we're speaking with Vignesh. He's the founder of Par Autonomy. Par is working at the intersection of defense, autonomy, and indigenous deep technology, building systems where software, hardware, and strategic intent collide. In a world moving rapidly towards autonomous warfare, simulation driven defense, and AI led decision systems, Par is tackling a question India can no longer avoid. Hi, Vignesh. Thank you so much for being here.
Hey, Drishti, thank you so much for having me. And thank you for that introduction. I think it's quite succinct what you had to mention about PAR. So, I mean, I'm an engineer out and out. I'm one of those few people nobody had to force into engineering, right? So, I always wanted to be an engineer. Did my mechanical engineering undergrad in Amrita University in Coimbatore. And then I went to the US to pursue a master's in robotics from Washington University. Worked there for about 4 years in Pittsburgh, which is the robotics capital of the world. Worked for a company that made thousands of robots for Walmarts, basically scanning the shelves of Walmarts. So I've been to more Walmarts than most people in the US. I've been to more US small towns than most people in the who have grown up in the US. And then 2020 happened, COVID happened. So the company I used to work for was over leveraged in the retail space. So everything came crashing down for them. Within a couple of weeks, that company got shut down because we had nowhere to use our robots. So I thought I kind of always wanted to move back, but I thought the disruption would make it easier, right? Like it's an easy. Sometimes the decisions get made for you. So I thought, okay, let me move back to India, right? And around that time, what I wanted was a role where I could kind of be in the room where the decisions get made, right? Be very close to the management team, but to like build out a product and build out a product team. So that I got that type of an opportunity at Asteria Aerospace. They're the second largest drone company in India. They're now also a Reliance subsidiary, right? So I worked there for about 4 years, essentially built out their product management team. I was the first product manager they hired, and then when I left, there were about 7 people in my team, systems engineers, product managers, designers, and so on. So got to see the drone industry, defense industry very closely through those 4.5 years. And kind of the mandate that I'd been given by them was to build out a product team and like streamline their products, help them launch a cloud software platform. I think that most of that mandate was done. So I thought it's the right time to like do what I've always wanted to do, which is build out in robotics out of India. So that's the story of how Par Autonomy came about. It essentially means a world or our world. And essentially it's Par means world in Tamil. I'm from Chennai. So Par Autonomy is basically how can we use autonomy, how can we use technology to protect what we hold dear, our world, right? So and that's basically the origin of Par Autonomy, how we came out to be. So 2024, we started in June. It's been about a year and a half.
That's a great intro. Thank you for that. We just also wanted to understand most of the, I would say, legacy players in the defense industry have usually been people who have been deep rooted into the defense sector. They either gather defense intelligence, they've either been in the tech side of defense for the longest time, or they have somebody in the team or in the co-founding team who has been part of say who have some form of an on ground experience. Who fulfills that expertise, that knowledge gap for you in your team?
Between myself and Nishant, he works on the business development, sales, and strategy side. So he has about 5.5 years experience working with a couple of different defense contractors. I met him at Asteria. Then he moved on to work with a defense contractor who basically was importing Israeli technology and deploying it here. So, and then, like I said, I have been very closely working with across different ministries and directly with like the stakeholders in defense on multiple tenders that I've seen through from the origin of that tender to eventually that system being delivered, right? So I think between the two of us, we take care of that. But I think that's broadly a great question as well. The radical innovation always comes out from the left field, right? Like it's not necessarily like, I think it's not necessarily, also, it's not about the biggest gun right now. When it used to be about the biggest gun, you needed to know the person who could make the biggest gun, right? So I think more and more it's about software. I think the probably the next 5 years would see more radical thought process in defense coming straight out of college, right? Somebody would say, okay, I can develop an AI algorithm that would be able to like stop the war before the first round is fired, right? And that might come out right out of college. So yes, the two of us fulfill that role, but I think it might not be as relevant as it was once. The way they're procuring is also changing. How the government thinks about this is also changing. They want people who think left field to come in and contribute to this. So I think we are in the conflicts of both those trends, right?
I mean, it's a great change because we've seen most of the legacy players being from that sector, and of course, there were these somewhere outdated regulations, like say the monopoly rule of if you're coming up with a new technology, there needs to be two incumbents for your tender for you to even be considered as a defense player, right? So now that these rules are becoming better, I think the space for innovation, especially in defense tech, is increasing. I wanted to understand what is the gap in the defense or the autonomy sector that led you to start with Par Autonomy?
See, I think fundamentally the way we think of this is essentially to say, hey, uh, very good hardware is going to be very important, but that is the ability to start playing the game, right? Like for you to be able to meet the enemy, you need good hardware, and that's a given. But the way future wars are going to be won is through software. Hardware is like, imagine, say you are like, hardware is the pawn or the keys. I mean, the different pieces on the chessboard, right? You need the piece on the chessboard. Of course, you can't start with just a pawn. You need all the pieces on the chessboard. But the thinking behind that chessboard, the person who's playing that game needs software to play that game well, right? I think that's pretty much it. We felt like there were a lot of players catching up on the hardware side. I mean, I'd worked in one, and like there was about a 10, 11-year track record of deep tech startups, whether that was in drones or unmanned ground vehicles, companies coming up with unmanned sea vehicles, companies looking at anti-drone systems. So the hardware play was, maturing, right? To some extent, at least, right? It's not the same as it could be in an Israel or a US or a Europe, but people were there and they were taking those big strides to put those pieces on the chessboard, right? Now you needed the software layer to like come good, which can then enable these pieces to be moved in the right ways to counter what the opponent is doing, right? I think that's pretty much it. We felt like the hardware was maturing. And in fact, that's why you see we limit ourselves to be the eyes and the brains of these different systems. We don't necessarily go out and build a whole new system. That's not what we want to do. We want to democratize the ability to perceive threats and autonomously respond to them. Right? Whether that is a drone or an unmanned sea vehicle or an anti-drone system, that's where we want to operate. So the layer that embodies this hardware and makes it smart is where we want to operate. And we felt like that was the biggest gap as well.
Yeah. No, no, absolutely. Yeah, we absolutely see that with unmanned vehicles becoming more and more prominent in land, sea, and otherwise. It's important to give them, I would say, the brain. So, like the reason where edge computing sort of comes into picture here, right? It's big now, and it makes a lot of sense. So, I think that's a great point. Thank you for that. And how would you describe the current state of India's defense technology ecosystem? What is happening? Where are we standing in terms of, say, the global ecosystem, where we could do better, where we're doing better, where we're currently, say, what's the best?
I mean, I'll give the it's see when you summarize a big industry, it's always an opinion, right? So I'll start with that caveat. So this is my opinion, right? I think the places where we can largely improve are one, like we'll start with how procurement happens in India, right? So one of the challenges in India is in the US, typically what happens is an operational requirement is told to the industry. The industry is told an operational requirement. So the uh, the defense sector there comes to the industry and says, this is what we want to achieve from a system. We're thinking in this direction. This is the outcome that we want to achieve. Can you come back and pitch product concepts to us that can achieve this outcome, right? Which is very different from what happens here, which is you generally get an RFI, a request for information, where a lot of different specifications have already kind of been mishmashed and put together, and you sometimes don't even know what the intended use purpose is, right? Like you don't know what they're trying to use this technology for, right? Where is it going to be used? How is it going to be used? How will a particular feature act as the differentiator, right? So you don't have this information, right? I think that's pretty much this, like that's where the road splits, and that has a lot of downstream effects, right? So one of the downstream effects of that is that then you are building to a spec sheet instead of building to a problem, and that also creates its own challenges, right? So that's one part where, like, say we can do better. The stakeholders can be a lot better about how they communicate the use case rather than a spec sheet, right? So, and the industry can also push back more. In fact, in some ways, it's easier for the industry to like just get a spec sheet, right? So they're also okay with it, because then you just need to meet those like obvious things, like 90 minutes of endurance. You just need to meet the obvious thing, right? In extrinsic aspects of the product, you don't need to think a lot more about it. You don't need to innovate a lot, right? So I think both stakeholders have a uh, kind of, it works. The status quo works for both stakeholders, but I think that leaves our systems worse off compared to like what a foreign company is able to do, right? Because they start with a problem statement. The second thing about that is that then it makes predictability of how many will you get to make over how long also harder, right? So if you know a problem statement, even if they don't tell you, you can say, okay, this is the number of, let's say logistics, right? This is the number of resources or mules that the army has. They want to replace the mules, and therefore these many number of mules they would need to replace with these many logistics drones. So I need to set up a production capacity of this much. I need to hit a yearly production run of this much, and that's, I need to build out a capacity for that, right? So when say the buyer starts with what the problem statement is and how much are they looking to procure, how fast are they looking to go, then the seller can also scale up to that, right? And I think that's another place where we can vastly improve, because if you see our ecosystem, everything is made to order. And there is a fundamental problem in made to order, is that you can't plan a great supply chain around a made to order mechanism, right? You can't drop prices, you can't leverage economies of scale, because you are making stuff to order, right? So you essentially get 1,000 quantity order, then you rig up all your vendors, and your vendors actually know now, boss, this guy needs 1,000 quantities, right? So he's going to give me the rate that I ask him to, right? So I think those are two aspects. I think focusing more on the end use case, having a better understanding and pushing for a better understanding on the end use case. And I think also going forward, a more clearer roadmap of how many systems are being required would kind of solve both these challenges. We as an ecosystem can solve more for the end user, the actual Jawan on the ground flying the drone, right? Oftentimes you will see bags that are as big as two people, and somebody expects one guy to carry it on treacherous terrain, right? That's because it's not really solved for the end use case, right? And the other side being the supply chain. So, like, capacity as a country to produce drones are probably in the tens of thousands, right? And best. And let's say China, the capacity is probably hundreds of thousands, right? And even a country like Turkey would be in hundreds of thousands. So I think that completely comes down to the unpredictability of the buyer, right? And therefore you can't really put money on scaling, right? And if you don't put money on scaling, you can't get to scale. And then if you can't get to scale, you get stuck doing smaller order quantities where your supply chain doesn't mature. So I think those are the two aspects where I would say we perhaps aren't doing as well. Coming to bed, what we are doing very well is that we are really now focusing on indigenization, right? We're saying, hey, it's not just that the end system needs to be made in India, its parts also need to be made in India. At least the critical parts need to be made in India, right? So I think that will take like 5-6 years to pan out, right? And as that pans out, I think things will get a lot better. Your costs will get lower. You'll be able to be more competitive, and only then does it make sense to export. So only if you're adding a high amount of value of the end system within your country does it make sense to export. Otherwise, what are you exporting, right? Like, say you buy everything from Israel and then you assemble it here, then you want to export it to a different country. That doesn't make any sense, right? Like, you aren't the one adding all the value. So I think that's a lot of
Yeah.
focus being put on that round. Credit to the government, credit to all the drone companies as well. Say for example, in that industry, right? They they know they're incentivized to indigenize, and a lot of times the conversation that we have starts off with like, hey, we are looking to buy this in India, right? Like, if not you, we're going to go to somebody else, right? But we are looking to buy this in India, right? So I think that is something that we do looking to very well. And it's quite important in these sectors that we are a little bit protectionist, right? Like, it's not like a different sector like automotive or say farming equipment. In this sector, being protectionist matters, because ultimately the easiest way to cut your force in half is to deny you service, right? Deny you the ability to operate these systems because you don't make it, somebody else makes it. So I think now the thought process is very clear. We want to make in India. We want the sub components to be made in India. And I think that's also changing a lot of how we as at Par Autonomy operate, but everybody in the industry operates and how they think about it, right? Even as a small company, we think, hey, is there an Indian supplier we can at least start the conversation with? They might not be ready, but like, can we have that conversation going so that when they're ready, it's a drop-in replacement for a Israeli part or a European part or an American part, right? So I think that's basically how I think it's panning out now.
How are the Indian, say, the counterparts matching with respect to the price points? You said that you prioritize Indian suppliers a lot of time. How are they matching with respect to the price points that, say, the foreign contemporaries have to offer?
I think
And
so. Yeah, I mean, I think you can't see. I think in this sector, right, you can't just go by price. Price is a factor, but you can't just go by price. You need certifications. You need the right type of testing that they have done, right? So I think for all that factored in, I wouldn't say there is a lot of arbitrage to be made by like choosing a local supplier at this point. The only thing that you can get away with is you're not paying customs duty, right? So 10 to 20% of that BCD amount, the border customs duty amount, you're not paying that, right? So I think apart from that, there isn't really a price arbitrage. But where it really plays out quite well is imagine, say, somebody, you're building a drone, Drishti, and I'm providing the perception components, right? And you would have agreed to a terms of repair with the army, right? Now, for you to be able to provide that service, a high quality of service and a reliable service, you need me also to be responsive, right? When I'm sitting in Israel, I'm sitting in the US, and you are my 10th or 20th or 100th most important customer,
yeah,
I don't have to service your parts as often or as like responsibly as I would an American company, right? And that actually translates into bad outcomes for the end user, which is the army here. Right? I think that's probably more important than price, right? Because these are systems that are going to fly for the next 5, 10, say sometimes 15 years. And you want serviceability to be factored in. And when you factor in serviceability, I think their indigenization is more important than even price. So it could be a little bit more
absolutely.
expensive today, right? But then over the long 5, 10 year cycle, if the service is better, then you're saving more money.
Yeah. No, no, absolutely. And of course, there are these a lot of externalities when it comes to working with external players. If push comes to shove, you know who they're going to prioritize, right?
Yeah, absolutely. That
So you spoke a lot about indigenization, but in your view, is there any specific defense stack, like which part of the entire defense stack do you think must be indigenous? If you had to pick one, the most important part of the
sure.
tech
I
stack.
see. I would kind of go back. So the army has a framework called UDA: right? Observe, orient, decide, and act. So observe, orient, decide, and act. Right. So the first two things are observe, orient, and decide. Right. So let's just talk about what. So before you need to do anything, they follow this principle of you need to observe what's happened. You need to orient that with the information that you have. Then you need to take a decision on what needs to be done. Then you need to act. A lot of the defense technology that we talk about is in the act bit, right? It's a gun, it's a grenade, it's a bomb. It might be, a frigate or like a INS Vikrant, which is like an war, like aircraft carrier that has gone somewhere to show force, right? So all of this is
Hmm.
a lot of the time we talk about the act part, right? But before that, you have the OOD, right? So therefore, I think that's where a lot of indigenization needs to happen. So that's why if you see so many satellite companies are coming because satellites help you to observe stuff that is happening in your territory, in the enemy's territory. And that's probably why there is so much emphasis on satellite technology. I think that same emphasis will come on the drone technology side, especially on the cameras, especially on the type of electro optics utilized to do the observation, right? So I think that's one key area where the technology needs to be indigenized, right? Second bit is the orientation. Like, so the software or the middleware layer, and that would include stuff like, tactical radios that allows you to take different pieces of information and arrange it in a way where like you can make sense of it, right? And then the design bit, which is the AI bit, as like, the number of pieces of information kind of explode, right? And say you're getting a false alarm that 100 drones are coming from this side and a real single drone that's, approaching from the other side. Do you have the autonomy or the AI layer to be able to decide on this technology and then get an action out, spit out an action that can be looked at by a person, and then the person decides to act on it or not, right? So I think I would say things that help the first OOD of the OODA loop is where a lot of focus needs to be put. Already, I think there's a lot of capability on the app side, right? Like we have the technology to build our own guns. We have the technology to like build artillery. That tech is there. It's the first O and D part that actually going forward will win you the war, right? Like that's the part that will prevent the war, right? When you know something's going to happen and you can prevent it at that point, you can stop an escalation, right? So I think I would focus on that. So electro optics, both on satellites, drones, unmanned ground vehicles, that's something Par does. And then the middleware layer, which is the software plus radios to stay connected, to stay communicate, to keep communicating, to orient all the information that you get from different sources. And then the decision layer, which is the AI, whether it's the edge AI on the drone or an AI that gathers all this information and presents it in a way where somebody can act on it more meaningfully. I think this is where probably a lot of effort needs to go in. And I think the government also thinks that this is where the effort needs to be put in, right? So there is a lot of emphasis on how we induct AI and like autonomy into like defense systems already being placed. So I think that's my thoughts at least.
So, just for the audience, if you could clarify what PAR is doing, per our understanding, you build perception payloads to mount onto the existing UAVs, UGVs, and USVs. But I would love if you could give a better overview of what exactly PAR is building in different domains.
Yeah. I think we'll start at the simplest level and then take it forward, right? At the simplest level, we build the eyes and the brain. Eventually, we have a plan to build the ears, which is radio technology or signal intelligence technology. But we build the eyes and the brains today. So the eyes are multi-sensor cameras that can see everything from the heat emitted from your body, right? All the way up to like what we see, which is the visual spectrum, right? And beyond. And different objects behave differently in different portions of the spectrum, right? So we, even at the darkest night, we'll still be able to see somebody, moving around, say a couple of kilometers away using our camera systems, right? So I think that's the eyes bit. And then the brains bit or the brain bit is basically we build visual language action models. That's a mouthful, but I'll kind of break it down. You can think of what we built as like a distant cousin of a ChatGPT. ChatGPT is a huge, like billion parameter, trillion parameter model. Versus what we have is a very, very small slice of that we have built that runs locally, that takes the input from the cameras, which is the visual part, then takes the input intent from the user, which is the language part. So the user says, fly along the border, make sure that no tank comes within a kilometer of the border. If that happens, track and hit that tank, right? So that's the language. The user has provided an intent through language. The vision is the camera that's looking for tanks. The language is what the user provides as an intent. The action here is the autonomy to be able to do this. When you know where the border is, you fly along the border, right? And then you understand that a tank has broken this instruction, like broken the rule that was set. And then you can fly in and hit that tank completely autonomously, right? So that's the visual language action model bit. And that's the brain part. So the synergy of these two is what provides autonomy to a drone, as an example, right? Or an unmanned ground vehicle or an unmanned sea vehicle. So we don't go out and build a drone or build an unmanned sea vehicle. We build a tech that sits on top of it that makes it agentic, right? That's the buzzword today. Essentially, we build a tech that makes it a physical agent. So the way we like to talk about it, it becomes a physical agent, right? The other way to think of it is today the drone is a tool. We make it into a teammate, right? So it's a tool today that somebody has to actively operate. And for the war, to win the wars of the future, you need it to be a teammate where somebody just gives it instructions and gives it inputs whenever necessary, and then it's able to operate autonomously. And both man and machine work together very closely as a team.
In the defense sector or in the environments and the use cases that you talk about, there are a lot of edge cases. Per my understanding, a lot of moving parts where there is stakes are very high. So how do you account for that? Because there isn't a um, I would say conventional way of looking at these situations, and again, it's not rule based, but
Absolutely right. So I think the way how we always talk about it is what's the cost of a false positive and what's the cost of a false negative, right? I think that's generally how we start. Like whenever we have this conversation internally, we say, hey, what is the cost of a false negative here and what is the cost of a false positive here, right? And you need to be very cognizant of that. I mean, just for the audience, just for them to understand, you don't want a false negative in cancer screening, right? Because it's okay for the doctor to get, for the patient to get frazzled a little bit, as
yeah.
long as you don't miss a possible tumor. That Because of the AI system, the doctor also didn't take a look, and then that caused bad outcomes, right? So in that case, you don't want a false negative. In a case where something is going to directly go strike, an enemy tank, you don't want a false positive. One, the ammunition is
Yeah.
very expensive. Second, what if it is not a tank, right? So that's always the question. And you don't want a lot of false, you don't want any false positives. So I think that's where we start. That's, I would say, the first principles way of looking at it. And we try to optimize for that. We understand that each action that the robot could take, what is the cost of a false positive or a false negative? And we optimize the model from that perspective, right? So we've developed our own action library and our own data set as well of these type of edge cases, right? Whether it's following a tank or like, looking for somebody in a trench, or it could be like looking to see if another drone has encroached your airspace. We've kind of gone out and gathered a very large data set, a lot of it from real world scenarios, right? Say some open source intelligence from like Ukraine or Armenia, or like even simulation work, which we have done. Like we've created a simulation. I think you mentioned simulation, right? So we also build out full simulation environments and then do training and testing on that, right? So I think it's a mix of strategies, collecting real world data as a part of it, making sure that we understand what the cost of like the false positive, false negative, and how we tune for that is very important. Lastly, it's also quite important that we test all of this in simulation, throw different scenarios at the AI, and then take a call, right? And ultimately, what we need to always fall back on is a person, right? So, for example, yes, you could be like you could be in a radio a dead zone, right? You don't want to turn on your radio and you don't want to talk to your operator, but then it's the operator's call. The operator sets the requirements of the mission, right? So the operator says, I believe there is a tank here. I've got an intelligence. I want you to go, not ask me for confirmation because your radio might give your position away. And I want you to go strike the tank, right? So ultimately, it's still a person deciding on what to do and what not to do. We've had autonomous systems before and now, and we will continue to have autonomous systems as well. Hopefully, what we can do is make sure that the collateral damage is reduced and the need to escalate is reduced, right? Ultimately, if both sides are losing robots to each other, I think that's a better world than people losing people to each other, right? So
Absolutely.
and that's why I wanted to just mention that we've had autonomous ways to like take out tap. It's just very crude autonomous ways, right? Like the mine is a very crude autonomous device that takes out a tap. Right. So I don't think the boogie about autonomy itself is bad. It's just that you need to make sure that the human's always in the loop and it's their intention that you're carrying out and nothing more or nothing less.
That's very well put. Thank you so much for this. I think that's the most well thought answer I have gotten to this question by far, especially after speaking to the founders working in the automation space. Thank you so much for that. Just again, another basic question that a lot of people who are not associated with defense in any way or form might have is that India and of course a lot of countries still import a lot of drones, anti-drone systems, and of course, other things often from suppliers who sell to multiple countries, right? As somebody who's not part of the ecosystem, one might just think that doesn't that neutralize the advantage in combat situations?
I think, yeah, that's a, that's a good question. I mean, see, I think this is kind of the person behind the machine kind of gets dissolved out. The procedure, the process, like the doctrine kind of always gets like muddled when you are only talking about like, oh, there's an S400. Like you can see how news coverage is, right? They talk about S400, S400, S400. There is a commander there who's been trained to handle the situation, who should be in a mode of panic, but isn't, knows how to like, you know, aggregate the information, understand what's going on, decide what needs to be utilized at the right time, and uses only just what is enough. Right? I think that's the doctrine and the training and the discipline behind the weapon and the machine that can make a phenomenal amount of difference, even if both sides start with the same machine. Right? So, and there are a lot of examples to this across different, countries, different wars, different eras. There's a lot of like evidence to suggest that the discipline and the doctrine can make a phenomenal difference beyond the machine, right? So I think that's one key part of it. Now, but I think that also is quietly changing because now what's happening is it's possible to throw so much of a single tech, right? Like so many drones at you. That there might not be that much time, right? And therefore, it could be more and more a technology versus technology fight. Like the amount of like the techification of war itself, right, might then mean that you still need discipline, you still need doctrine, but the gap that you can create through better processes might be diminishing, right? So I think while that existed, the influx of more and more technology kind of means that you also then need to be at the cutting edge. You can't afford to fall behind, right? So, I mean, I'm not sure a lot of people would have imagined something like Op Sindoor having a lot of dog fights, right? Because that's what we see in movies. I'm sure there were
Hmm.
no dogfights. Almost everything would have been fired from beyond line of sight, right? Nobody would have seen the other person in a traditional sense. They would have seen them in the radar, right? But they would not have seen the other side. So your ability to see the other side without making visual line of contact, right, is kind of determines the outcomes, right? So I think going forward, technology is quite critical.
What form of government intervention surveillance from, say, the authorities is into picture when you're building a defense tech company in India? What is the level of autonomy do you have with respect to choosing what to make, and of course choosing who to sell to, pricing, etc.? And just wanted to understand a little bit what the landscape is.
I think one thing that we need to kind of realize is, at least in India, everything is bought through an RFI RFE method, predominantly, right? It's all based on the bidding system, right? So one of the things that, and also it's based on the lowest first bidding system, L1 bidding system, typically.
L1 system,
Yeah.
correct? Yeah.
So I think there's a lot of pressure to like reduce price. And that probably is the biggest difference in India versus outside, right? So, and now they're starting to introduce more T1 plus L1, like who's the technology first, who gets the best performance, mix that into the L1 category, right? So, but it's very formalized. I think we might not go there, but that's the essence of it. It's the L1 plus T1 system. So, price is probably where the government has the most say by forcing people to participate in a lowest first tender, right? Like that, therefore, is probably where the government has the most say. The other side of this is it's a fairly objective technical evaluation at the technical evaluation stage, right? So, once you go to the evaluation, it's 90 minutes versus 91 minutes. And the person getting past that 90 minutes qualifies, the person at the 89th minute fails, right? So that part is quite objective. I would say the part that's not necessarily as objective is whose specifications end up in the RFI or the RFP, right? That requires a lot more like directly working, indirectly interfacing, trying to like get your systems to a demo, trying to be the first to that particular nodal officer or trying to be the first to that particular head of command. That's probably where a lot of the externalities, your ability to have a good business development team and all of those things come in. Because once that spec is there in the RFI, everybody is competing in a relatively fair game. And then whoever has the ability to provide those number of systems at the lowest margin or at no margin, because if they're trying to establish a market, they're new, they're trying to establish themselves in the market, they're okay for fitting any margin, they then end up winning, right? So I think price and specifications is where the government has the most say, and that's how it plays out as well. Specifications get decided in the RFP document. Price kind of gets decided because of the downward pressure when you're competing to be L1. Outside of that, there isn't necessarily a lot in terms of what you can build or cannot build at the moment. Right? Obviously, you need to have a defense industrial license. Once you start involving in a live ammunition and things like that, you need to have a defense industrial license. There are certain clearances that you need at the state center level as well, which we don't have because we are not in that game. Perhaps the only thing that can get simplified is the import regime, right? To test them out, you're trying to bring different parts together, test things out. And in that R&D phase, it will be much better if the import rules can be simplified, because we are generally not importing the most common item, right? Like, it's not like we're importing a very common item that the customs officer has seen a lot of times, right? So we run into a lot of trouble with like, importing like a new type of sensor or a new type of PCB manufacturing technology, right? So there's a lot of friction there. I think that there is anything that can be solved for. There can be an R&D mandate that kind of allows for imports up to a certain amount or a certain number of units that will make R&D faster, right? Research and development faster. And that would be the only thing where currently the regulation isn't as helpful as it can be. Because we get treated the same way, say, somebody importing toys to sell in a retail store gets treated, right? And that treatment isn't fair because what we are trying to do and what they are trying to do is not the same.
Yeah, no, absolutely. In fact, just to tie it back, I just had a conversation previously with the founder who's building in genomics in India. And she was talking about how the regulation and the policies in India with respect to R&D, there's a blanket policy in place where they're taxed. So she was talking about the taxation of R&D funding that they get. And I think it all ties, this part ties back that India needs more R&D structured, R&D centered policy making. But we do see IDEX need to, especially in the defense sector coming in. Could you talk a little bit more about if they have helped you?
Yeah, we are not directly a beneficiary while we are attempting to do that. Like we are trying to participate in like upcoming IDEX challenges. What I wanted to say, IDEX is definitely helping, right? But IDEX is one among many. Oftentimes, what happens at like talking about R&D, right? What happens at the IDEX stage is it is already technology that has 4 or 5 layers. So imagine, say, like the camera system that we built. So before that, there is the sensor or the CMOS sensor, the silicon, right? Before that, there is some fundamental physics in terms of semiconductors, right? And we sit like on a pancake of tech, right? So IDEX generally is for the top pancake in that stack, right? So a lot more money needs to go to the bottom of the stack, right? Where the chance of failure is also way, way higher, right? And that's the weird thing about technology is that the bottom of the stack is where the failure rate is the highest. The top of the stack is generally a lot more stabilized and a lot more, you can be a lot more successful. Somebody trying to make a new rocket fuel is probably going to be way less successful than somebody trying to build a new rocket launch system, right? And I think a lot of what IDEX does is the top of the pile, not necessarily at the bottom of the pile. And bottom of the pile innovation is kind of what accelerates the entire ecosystem, right? That's what brings prices down. That's what creates real indigenization, right? So I think that's something that we can pay more attention to. I mean, from my time in the US, I knew, for example, the type of tech that we were working on. Like I used to work in a cyborg locust, like cyborg grasshopper lab, right? Like where we used to like put electrodes in them to try and sense bomb making chemicals. Now the rate of this is absolute bonkers research, right? Like the rate of failure is probably phenomenally high. I don't think we've still made one. That lab has made one grasshopper in one uh, airport that has found one bomb. I don't think that's happened. But when you do that level of research, like deep research, 10 engineers come out with like brain computer interface understanding. 10 engineers come out with like how to make those electrodes. 5 engineers come out with like how to build robots, right? Like that is probably what's not happening, right? I think we are still, IDEX still fulfills the requirements of the army that can be army or navy or air force that a private company can take up, which means it's not necessarily the deepest deep tech, right? the, they know it can be built versus what I'm talking about as the type of research is bonkers ideas, right? At all that can only happen in a research lab, right? And that'll, if even if it doesn't produce a result, it produces 5 papers, and I think that's probably where more of the R&D funding should continue to.
No, absolutely. And we hear a lot about India trying to replicate a lot of the global models with respect to research, like setting up research foundations. And I mean, we technically don't have that in place. But do you think slightly more privatized approach, equivalent of how DARPA funding works in the US?
Yeah,
Do you
something.
think?
I think more outcomes focused, probably, right? I mean, I remember that the lab I used to work in, it was the professor's responsibility to like ensure funding for the lab and also that ensure that outcomes were delivered towards those funding. And his tenure was only like the professorship was guaranteed, right? But the funding to the
Yeah.
lab was not guaranteed. The funding
Yeah.
to the lab was based on what he was willing to get his team working on and what type of results he was producing, right? So I think focus on outcomes probably is like a really critical thing, and that can happen more when it's a little bit more privatized, right?
Hmm.
I think the other thing is, I mean, there's a cultural thing which is we still are quite afraid of failure, right? Like we don't consider failure as a normal stepping stone towards like doing something innovative or successful, and therefore the
Hmm.
ideas will always tend to be either copied or like derivative, right? Like you get original ideas when you really don't worry about everybody looking at you. And I mean, there's a company in the US called Spin Launch. I really like this story where like they just spin something up so fast that they can throw it directly into space, right? Like they can throw a satellite into space by literally using a slingshot, right? Like, so I think for somebody to say, I want to build that, are we as a culture like open to that, somebody saying that and then going out and doing that, right? So I think that's probably a big factor as well, right? Like it's not just the structure or the incentives that you set up. It's like as a culture, are you ready for those type of structures and those type of incentives?
Yeah. Yeah. And those need to be, again, cultural. Again, culture ties back to funding, ties back to, the opportunities that you get. So coming
Success
to
that will
that.
come, right? Like, so I think that will come with success as well. I mean, like, one Agni Cool will breed like 20 rocket companies. right? And then those 20 rocket companies will bring like 200 satellite companies, right? I think that's also a factor. Like how we have to very seriously ask ourselves, how long have we had this ambition to be a deep tech country, right? Like maybe like 10 years, right? So we need to be very realistic about what's possible in like 10, 15 years as well, right? Like it doesn't make a lot of sense to like point fingers and say, hey, look at America or like look at, say, Europe. I mean, one thing is that VC funding has been a thing for like 70 years in the US, right? So maybe 25 years if you're a little bit liberal in India, right? So I think that's, I mean, it'll take time to play out.
Makes sense. Coming to the economics of it, how is the funding ecosystem looking like with respect to defense tech? What is the appetite? Who are the primary funders in this space?
I mean, so I mean, we are funded. Like we've been funded by venture capitalist for a pre-seed round of about I think $400,000. It happened in August of 25. So I mean, we are institutionally funded. But I think before that, what we experienced a lot in 24, I mean, late 24, as we started having these conversations, there were a lot of VCs saying, hey, I think the technology needs to be dual use. Otherwise, it's very difficult for us to back a company, right? And one of the, like, it's something that I have learned from like spending time at Asteria and looking at like who the real globals, like movers, shakers and movers are in the defense space. They don't think about it as dual use. They build the best military technology and then it gets licensed because it's the best technology in that segment to dual use purposes, right? So I think, but that's changed more. And there are still most VCs we talk to would bring the point about dual use. And then we are also confident now to say, hey, I don't think that's the right way for the company to go. We want to double down on this. This is where like we want to meet the moment, right? Like this is where the requirement is. And it's not just about what we want to build, it's the requirement of today. And we want to meet the moment. And so we'll stick to this, right? So I think that's changed a lot. I mean, you partly post-op Sindoor, I think a lot of people have also realized that there is need for this technology. So I think their mindset has also changed. So a lot more VCs are very comfortable with us saying, hey, yeah, there are use cases for autonomy. Like we have a capability called precision negotiated landing, right? Like where we're able to like land on a particular spot, negotiate the landing in case there's a person sitting there or moving there, right? So that type of tech will have a use case in say, logistics, right? Like for example, delivering food with a delivery drone, right? It can have a use case there. But the way we communicate it is, hey, we know the technology will have a use case. We're not going to go after it. We're going to make the best version of it, and then we're going to license it to somebody who needs it, right? So now there's a lot more VC understanding of that model and acceptance of that model, and that model can work, right? So I think that has changed for us and for the VC. The concern is defense sales in India are very lumpy, right? Like you have extraordinary years and then quiet years and then extraordinary years and quiet years, right? So I think that's a very fair, fair underwriting risk that they also talk about, right? Quite commonly, these are the 2 points that are brought up, right? Like one that we have to acknowledge, and the other where we say, hey, no, we want to stick to our guns and we want to build in this space. See, VCs in those spaces now saying, hey, we want to make a deep tech investment. Talk to us about what you're building, right? I think the challenge with them is for them to understand what are the signals that will that the company needs to be making for it to be successful. They have not figured that out yet, right? So I think then the challenge is a little bit more tricky in the sense we are also trying to figure out, obviously, we are trying to figure out product market fit, what we are going to build, how we are going to take it forward. They are trying to figure out what is the recipe to win in this space, right? So I think those matches are slightly more difficult to make because they are also new to the space, right? So I think, but a lot of interest is there. I think we are pleasantly surprised by how the last few months have been, where people have been reaching out to us, trying to understand what we're building and like how they can be a part of it. I think the part of this would also be more regularization in the procurement space. In fact, I believe a lot more institutional capital will find early stage startups if there can be more regularization in the procurement space. Say, for example, if it moved from an RFI, RFP thing to saying, we want 10,000 quantities, we will give this to one company over the next 7 years. Every year, we'll procure a certain number of units, and if they deliver that well, we'll go to the next stage, right? This will make underwriting a lot more easier, right? I think that's partly the VC's challenges as well.
Just one last question. You mentioned something called signals for success. That's something that you think is hard to capture, hard to understand the pulse of the industry until unless you are in that. So for defense tech, could you tell me what do you think are some of the signals for success, early signals for success that you've caught on to that a lot of
Yeah.
other people in the industry haven't?
See, I think I would say this is more of a founder market fit then, right? Not necessarily the company. Is your network matters a lot, right? I think how you measure this is a different thing, but like your network, like you need to be in a position where different stakeholders feel very comfortable calling you and saying, "Hey, this is the problem we're having in this trial or this tender, right? We are having a problem." They are asking us a question and we don't have an answer, right? Like, do you have an answer? Do you understand this well enough? Like, it might not be your company, it might not be like the product that you're trying to build, right? But that is the biggest factor, like to position yourself and your company as the technical know-how hub within the industry is probably going to be the biggest, in my opinion, the biggest signal, right? Because everything else follows from that, right? Like your ability to understand the space well enough, the technology well enough, the user well enough to say, okay, this is exactly what they're asking for and this is how you go build it, right? So I think that I would put it as a product domain understanding, right? So I think that's probably the biggest thing. You understand the domain well enough, the product well enough, the user well enough to be able to think through a solution, right? And it need not be for what you're building. Those opportunities might be for what you're building or what you're focusing on, or something else in the industry that somebody else brings to you, right? Are you able to like address that, right? I think those people will go on to build good technology companies in defense because it's very many stakeholders, very complex problems, and you kind of need to like wrangle all of that and then put out a technology solution, right? So I think that's one part of it, right? I think the second part of the signal I would say is resilience. I mean, a lot of times these, like for example, there is a particular I can't mention a lot about it, but there's a particular order where we are trying to work directly with the army for anti-drone system, right? Just the part where they've accepted our solution, on paper solution, where they've accepted our price and they've said, okay, we look to buy one of these. Wait, right? That part took about a year, right? So that's you need to be extremely resilient, right? You need to believe in what you're building and you need to consistent. You need to be ready to follow up endlessly. You need to understand that hey, the person you're working with at a kernel level, say you might think, oh, kernel level, he has the decision making power, right? There are 20 people above.
Yeah.
So there are 20 phone calls that need to go one step above, and above to get that decision made, right? So you need to have empathy for the user, for the buyer as well, in that they need this, they understand what you're building, but there are limitations to their ability to take executive action and decide on what to buy, right? So I think that resilience and empathy on the on what the user is having to go through to end up buying your product, I think those are two things I would say are quite critical. How well you understand the technical domain, and then how well you're able to stay on track, because a lot of uh, projects will come your way. Somebody will come and say, hey, can you do a service with drones to like digitize petroleum corridor, right? Then some another opportunity might come where somebody wants to put a drone show with like a lot of drones and a lot of lights. There will be other revenue potential opportunities, and that's kind of what VCs also say, do you want to be dual use? And you I think the companies that succeed are companies that say, no, this is exactly what we want to do. It'll take time, but we'll do it well, right? I think that's probably a major signal for success, probably even more important than the first one, because now you can find the person who will be able to build you the technology. From a founding group, the core group needs to truly believe that this is something we need to build. It'll take time, but it's okay. That's okay, and that's how it is.
Thank you for summing it up so well. I think defense is one sector where I've noticed founders with exceptional maturity with respect to early signals, early wins. I think it's great to be building in this sector. I'm so glad I did this. Thank you so much for your time. I hope more and more people follow your journey after this.